All right, let's dive into something that feels straight out of science fiction, but it's happening right now. AI is designing computer chips. And the craziest part? We have almost no idea how it's doing it.
So just think about this for a second. What if the very engine of our future, our most advanced, most powerful technology, was a complete mystery to the people who created it? What would that even mean for us?
Okay, let's start with section 1, the unexplainable chip. This is the new reality, and it's kind of a mind bender. AI can now design computer chips that are way more powerful and efficient than anything a human engineer could dream up. You know, the tool has officially outgrown its creator, and this gets right to the heart of how bizarre this is. See, a human-designed chip is like a city plan on a perfect grid. It's orderly, it's methodical, every connection makes logical sense. But an AI-designed chip, it's more like an ancient, sprawling city that grew over centuries. It looks chaotic, almost alien. But somehow, it just works with this strange, brilliant efficiency that we just can't wrap our heads around. And because their inner workings are so completely unintelligible, engineers have given them a name. They call them a functional black box. So what exactly is a black box? Well, it's actually pretty simple. You know what goes in, and you know what comes out. But that whole process in the middle, how it gets from A to B, that's a total mystery. We can see the magic happening, we just have no idea how the trick is actually done.
So, how on earth did we get to this point? Let's get into it. Section 2, AI enters chip design.
This definitely didn't happen overnight. I mean, in the early days, AI was basically a helpful intern, you know? It would optimize little parts of a human's design. Then, with deep learning, it got a promotion, started taking on more complex jobs. But the real revolution is what's happening today. Using something called reinforcement learning, the AI isn't just an assistant anymore. It's the master architect. It's designing the entire chip all by itself. Now, with all this mystery, you've got to be wondering, why would we ever use this? Well, it turns out the reasons are incredibly compelling. Which brings us to section 3, the AI advantage. The benefits are they're too big to ignore. For one, you've got pure performance. These AI-designed chips are faster and they sip energy. They can also be custom-built for really specific, demanding fields, like in medicine or for self-driving cars. But here's the real game changer for the industry: time and money. Chip design is notoriously slow and expensive. Well, AI just completely changes the equation. It automates the whole process and crushes development time from years down to, in some cases, just weeks. But as you can probably guess, this kind of power doesn't come for free. When you hand over the keys to a black box, you introduce a whole new world of dangers. That brings us to section 4, risks and concerns. And these dangers really stack on top of each other. First, you've got dependence. We're relying on a technology we literally don't understand. That creates a huge security blind spot. I mean, how can you possibly fix a flaw you can't even see? And that leads to a crisis of accountability. When a black box system fails, who's to blame? The AI? The engineers who deployed it? And that risk becomes absolutely terrifying when these are the chips running our power grids, our hospitals, or our financial systems. So, where is all this headed? What does the future look like? Let's talk about it. Section 5, the future of AI design. And don't for a second think this is just about faster phones or computers. This whole design philosophy is going everywhere. We're talking about smarter medical devices, more efficient self-driving cars, entirely new ways of manufacturing things. We're not just changing what we build anymore. We are fundamentally changing how we build it. So, this all lands us squarely on a tightrope. On one side, you have this breathtaking, world-changing innovation. And on the other, you have these profound, maybe even scary risks. The single biggest challenge we face now is figuring out how to race forward without falling off. This isn't just a tech problem anymore. It's the balancing act of our time. And so we are left with the one question that's at the very heart of this entire revolution. It's the one we absolutely have to answer as this technology gets woven deeper and deeper into our lives. how do we ever guarantee safety when we can't even look inside the box?